So guys, here in this video I am going to discuss with you that how can we find the mean, variance, standard deviation and the distribution function of a discrete function. So now let's discuss that by using one or two example. So see here that if you follow the question, it is given that a random variable, here given that x has the following distribution, like these points are given for x, that is 1 2 3 4 8 9, and corresponding the p of x is also given, that is the values are k 3k 5k 7k 9k 11k. And here we have to first find the value of k, then we have to find the mean, variance, standard deviation, distribution, and p of x greater or equal to 3. So now first of all we have to know that what is discrete distribution. Actually discrete distribution contains some points that are like 1 2 3 4 8 9, and these points are made, these points 1 2 3 4 8 9, these are known as the spectrum points. Spectrum points, and the corresponding function p of x, it is known as the probability mass function. It is known as the probability mass function, that is the p of x. And now, and we can say that the function p of x is said to be probability mass function, or in short we will write it PMF if summation over p of x is equal to 1. And now this relation will lead us to find the value of k. So how can I find? That is, if this is a probability mass function, if we assume that the p of x is probability mass function, and before solving it, that sometime in the books it is given as fi. Okay, so in that case you have to write that summation fi is equal to 1. This fi is also known as the probability mass function. So now what is, now how can we find the value of k? So here, to find the value of k we will use the relation, that is summation over p of x is equal to 1, and we can write it, that is I is equal to minus infinity to plus infinity, or actually this is, we can write minus infinity to infinity p of capital X is equal to xi is equal to 1. Okay, so now if we use, that is here, from here we can write that is p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4 plus p of x is equal to 8 plus p of x is equal to 9 is equal to 1. And the corresponding value of these functions are k, 3k, 5, that is p of x is equal to 1, we get k, x is equal to 2, this is 3k plus 5k plus 7k, and the 8, this is value is 9k plus 11k is equal to 1. And if we sum, that is 3k 4k 9k 16k 25 36k, so we will get k is equal to 1 by 36. So now from here we can write, or we can rewrite this distribution table by like this, that is if this is for x, this is p of x for the value 1 2 3 4 8 9, we can put the value of k here, that is 1 by 36, 3 by 36, 5 by 36, 7 by 36, 9 by 36, and 11 by 36. So this is the value. So now this is the value, that how can we find the value of k. Now here I am going to discuss with you that how can we obtain the distribution function. This is the main criteria of this video, that how can I find the distribution function of a discrete function. So here now in the in this slide here, I'm just going to show you that how can we find the distribution function. So see here that these all we find here, that is here we know that the value of k is equal to 1 by 36, and the distribution function, you have to remind that the distribution function is cumulative. Distribution function is cumulative, and it is defined over the real line minus infinity to plus infinity. So now see, and the distribution function is defined by capital F of x. And so now see here that how can you find the distribution function? See that here, if we consider the region minus infinity less than x less than 1, that means if we consider the real number like minus infinity, this is 1, this is 2, this is 3, this is 4, suppose this is 8 and this is 9, so on. So see here then minus infinity to 1, this function is not defined over, so now from here you can say that f of x is equal to 0. And in the next, if we give it that 1 less equal to x less than 2. So in this case, we can write that f of x is equal to, that if we write here, this is I is equal to minus infinity to x pi. So from here, can we write 2 or x here pi, that is minus infinity to 1 pi plus 1 to x pi. Here the value is k. So this is k, that is the value of k is equal to 1 by 36. This is 0. Similarly now, if we find the area, that is 2 less equal to x less than 3, so f of x will be, that is minus infinity to x pi. That means it will be k, that is it will the cumulative function, so it will take my k plus 3k, so it will be 4k. Now similarly, if we take the point 3 less equal to x less than 4, in that case f of x is equal to minus infinity to x, and here we have to take the previous one, that is and so here we can write 4k plus 5k is equal to 9k. And now if we take the point 4 less equal to x less than 8, then f of x, it will be minus infinity to x pi, that is 9k plus 7k, it is 16k. And let 8 less equal to x less than 9, that is f of x is equal to, all are the cumulative function, so we will find that is 16k plus 9k is equal to 25k, and the 9, and for here we can write that is x greater than 9, we can say that f of x is equal to minus infinity to x pi is equal to 25k plus 11k is equal to 36k. So all these are the functions, that is f of x is equal to 0 at the point minus infinity less than x1, the value is 1 by 36 for 1 less equal to x less than 2, 4 by 36 for 2 less equal to x less than 3, this is 9 by 36 for 3 less equal to x less than 4, this is 16 by 36, that is 4 less equal to x less than 8, 25 by 36, that is 8 less equal to x less than 9, and this is 1 for x greater than 9. So I hope you understand that how can we find the distribution function. So now you have to write this one in a comparative form. So here I'm just going to write it, or if you follow this one, that is, we have to just write it in the form that f of x is equal to 0, then 1 by 36, then 4 by 36, then 9 by 36, and you have to write the respective region in a font. That is, here you write 0, that is here minus infinity less than x less than 1. This is 1 less equal to x less than 2. Then write 4 by 36, 2 less equal to less than 3, 16 by 36, then 25 by 36, and then 1. So this is the distribution function. So now here I'm just telling you, or I'm just show you one thing, that how can you find the mean and variance of a discrete distribution function. So see that if we take this one, okay, so here if we follow this question, that is the value of x and px that is given, that is this is given by like this. Okay, let's do it. That is, this is given by x and p of x, that is 1, 2, 3, 1, 2, 3, and then 4, 8, 9. Okay, 1, 2, 3, 4, 8, 9, and the corresponding p of x are k, 3k, 5k, 7k. 5k, 7k, 3k, 5k, 7k, 9k, 11k. 9k, 11k. Actually, we know the value of k is 1 by 36. Already we find it. The value of k is equal to 1 by 36. So here in this slide, I am just going to discuss you that how can you find the mean, how can you find the variance, and how can you find the standard deviation. The mean of the formula, that is I is equal to minus infinity to infinity IPI. So what are the I? I are the spectrum points. These spectrum points are known as the I, and Pi is the corresponding this value, the P of x. So here if we use this formula, that is we get 1 into k plus 2 into 3k plus 3 into 5k plus 4 into 7k plus 8 into 9k plus 9 into 11k. So here from here we get k plus 6k plus 15k plus 28k plus 72k plus 99k. And if we simplify, so what we get, that is 7k, 15k, 22k plus 50k, 50k plus 72 plus 99. Okay, so I just check the value here. 1 plus 6 plus 15 plus 28 plus 72 plus 99. So it will be, the value will be 221k or 221 by 36. And so if we round up with it, we will get the value will be 6.14. So now we have to find the variance. So how can we find the variance? The formula of variance, this is known as E of x mean, and the variance that is defined by sigma square, that is E of x square minus E of x whole square. So E of x square mean, we can write it that summation over I is equal to minus infinity to infinity I square pi. That means, so from here what can we write? That is 1 square into k plus 2 square into k plus 3 square into k, 1 square into k plus 2 square into 3k plus 3 square into 5k plus 4 square into 7k plus 8 square into 9k plus 9 square into 11k. So that is k plus 12k plus 45k plus 112k plus 64 into 9 576k plus 891k. So now if we simplify, we will get that 58 plus 112 plus 576 plus 891 like this. Okay, so we will get from here 1637k, that is 1637 by 36. So the variance will be 1637 by 36 minus 6.14 whole square. So we will get the variance will be 7.7727, and the standard deviation is positive square root of variance, that is root over answer is equal to, we will get 2.79. So this is the finding of the variance. So I hope you understand that how can you find the distribution function and also the mean and variance and also the standard deviation of a function. So in the next problem here, in this problem here, I just want to show you that how can I find the distribution of this function. So here similarly, what is the question, that we have to find the value of k and also we have to find the distribution function. So here this is f of x is given, so here we can easily that summation if I is equal to 1, or that is I is equal to minus infinity to infinity. So from here we can easily find that is 0 plus 2k, you can write that on 0 plus k plus 2k plus 2k plus 3k plus k squared plus 2k squared plus 7k squared plus k is equal to 1. And if we simplify, we will get 10k square, 7 to the 9, 10k square plus k, 3k, 4k, 6k, 8k, 9k minus 1 is equal to 0, or 10k square plus 10k minus 1 is equal to 0, or 10k k plus 1. So from here what we get, that k is equal to minus 1 and 1 by 10. So now see that the probability is never be negative. Probability is never be negative. So k is equal to minus 1, k not equal to minus 1. So we will take the value of k is equal to 1 by 10. So now we can write, or you can write it here. This is the value, this is 0, this is 1 by 10, this is 2 by 10, this is 2 by 10, this is 3 by 10, this is 1 by 100, this is 2 by 100 plus 7 by 100 plus 1 by 10. So whatever, so now we have to find the distribution function. So see that here again, if we consider the line minus infinity to plus infinity. So this is minus infinity, this is a point 0, 1, 2, 3, 4, 5, 6, 7. So see here that up to, if we consider minus infinity less than x less than 0, the distribution function f of x, it will be 0 because it is 0. Or if we use here minus infinity to x pi, this is 0, or fi here. Here it is given f, so here I use fi. So, and then if we use minus infinity less than x less than 0, and also if we use 0 less than x less than 1, so that will be also 0. That will be also 0. And now if we consider 1 less equal to x less than 2, then f of x will be minus infinity to x fi, that is before 1, before 2, it will be the value of k, that is 1 by 10. Now if we use 2 less equal to x less than 3, then f of x will be 2 less 2 less equal to x less than 3. That means this is a cumulative function, so we have to consider minus infinity to 2, and here minus infinity to 1, that is the value is 0, and the value is k plus 2k. So the value will be k plus 2k, that is 3k. Next, 3 less equal to x less than 4, then f of x will be, if we follow the function, that is minus infinity to 3. So here will be 3k plus 2k, it will be 5k. And then if we consider 4, if we consider it is 4 less than 4 less equal to x less than 5, so it will be 5k plus 3k is equal to 8k. And then if we consider it 5, so here I have to consider a new slide, that is 5 less equal to x less equal to 6. This here I write it here. Okay, I'm just mark it. This is 0, this is 0, this is for 1 by 10, 3 by 10, it's 3 by 10, this is 5 by 10, this is 8 by 10, 8 by 10. And now if we consider the function is 5 less equal to x less than 6, it will be 8k plus k square, that is 8 by 10 plus 1 by 100, that is we will get from here 81 by 100. Okay, 81 by 100. And next we have to consider these two, that is 6 less equal to x less equal to 7, that is if we consider 6 less equal to x less than 7, we will get 81 by 100 plus 81 by 100 plus 2 by 100, that is 83 by 100. And at last we will get the 7 less equal to x less equal to, or here we will consider that x greater than 7, that is we will use here the function 83 by 100 plus 7 by 100 plus 1 by 10, and if we simplify we will get the value is 1. The value is 1. So now see here that this is the value for the minus infinity less than 0, we get the function 0, or we can compare it at a time, that minus infinity less than x less than 1, f of x is equal to 0, then 1 to 2 the value is 1 by 10, then 2 to 3 the value is the k plus 2k, 3k is equal to 3 by 10, 3 less than 4, it is 5 by 10, then 4 less equal to x less than 5 will get 8 by 10, then 5 less equal to x less than 6 will get 81 by 100, and for 6 less equal to x less than 7 we get 83 by 100. So see here that when you find the distribution function of a discrete function, you have to just follow one thing, that is the cumulative, and we have to add, when we find that is 1 less equal to x less than 2, we have to add all the previous one and whatever, that is if you follow it again, I just discuss it, that if we follow minus infinity to 1, this is 0, the value is 0. When you follow the 1 less equal to x less than 2, you just follow, that is fi, that is k plus 2k, k 1 less than 2k. Then when you find the 2 less equal to x less than 3, that means we have to follow these two. Then when we find the 3 less equal to x less than 4, then we have to add all those. When we find the 3 less equal to x less than 4, then we have to add those. Or 4 less equal to x less than 5, then we have to add all those. When we will find the 6 5 less equal to x less than 6, then we have to add all this distribution and all these frequencies on the distribution, and when we find the 6 less equal to less than 7, we have to add all these frequencies, and for the last we will get 1. If you at the last point, the end point, if you not find the sum of the distribution function 1, you can assume that your calculation is wrong. So I hope you understand that how can you find the distribution of a discrete function. So thank you for watching the